Hi, in this video, we are going to talk about recursive sequences that we learned all the way back in Algebra 1. Now, with normal functions, we know that we could plug in 1 and 2 and 3, and we could see those values in the table. We could also plug in 1.5 or 3.2 or 6.7. The point is, we could plug in decimal values for x. However, sequences are discrete functions, meaning they are only defined on the set of whole numbers. For example, there is no 12.5 term. There's the 12th term and the 13th term, but nothing in between that. So we have the first term, the second term, the third term, the fourth term, but no decimal values in between. So if you're graphing a sequence, we do not connect the points because there are no decimal values in between to connect. Now, a recursive formula generates the sequence by using the previous term. Now, in general, how we use notation to describe a term is A sub n. Notice how I put the subscript beneath the line, just like we did for logarithms with the base. Now, A sub n is any term, but how do you indicate the previous? How do you go backwards? You subtract 1. So this represents the previous term, A sub n minus 1. Now, recursive sequences, or rather the recursive formula, has two parts. The first part is your starting term. Where are we starting at? And then the second part is the pattern that we need to use. And the pattern has the previous term involved. So let's try an example. Now, do remember that if we have a sequence such as 1, 3, 5, 7, and so on, I have A sub 1, A sub 2, A sub 3, A sub 4. And I'm saying sub because it represents the subscript. You can't just say A4. Let's talk about how we use recursive formulas to find the sequence. Now we have our starting term and we have a pattern. It's two parts. This is how I know it's recursive. We're going to take our starting term, and our goal is to find the first 4. So we're starting with A sub 1, that's first, A sub 2, A sub 3, and A sub 4. Those are the first 4 terms. If it said the next 4, that would be the second through 5th, because the first term would not be included. Anyway, the pattern is the previous plus 5. So the previous plus 5, previous plus 5, previous plus 5. We're just going to keep repeating the pattern. So we have A sub 1 is negative 4. A sub 2 is the previous plus 5. Well, the previous was negative 4. And negative 4 plus 5 is 1. Now for the next one, it's the previous plus 5. Well, the previous was 1. 1 plus 5 is 6. A sub 4 is the previous plus 5. The previous was 6, and 6 plus 5 is 11. Now, if you could do that in your head, very happy for you, but you do need to show work. You can't just write the answer. So our first 4 terms are negative 4, 1, 6, and 11. Let's try another one. We have the sequence is defined recursively. How do I know they're giving me something that's recursive? You have 2 parts. I have my starting term and I have my pattern. So what do we want? We want the 4th term. So I have A sub 1, A sub 2, A sub 3, A sub 4. With recursive formulas, you can't just jump to the answer. You have to find each one along the way. Now, A sub 1 is -2 because they said so. What's the pattern? The pattern is 3 times the previous plus 1. So 3 times the previous plus 1. 3 times the previous plus 1. 3 times the previous plus 1. We have the second term is 3 times the previous plus 1. What was the previous? -2. 3 times -2 plus 1 is -5. The third term is 3 times the previous plus 1. What came before this? -5. So 3 times -5 plus 1 is -14. The next term is 3 times the previous, which was -14, plus 1. Now I believe that's -42 plus 1 is -41. So now I want you to try the next few examples on your own. Make sure you show your work. Even for the multiple choice, you should be doing what I am doing in this video for the next 3 problems. Good luck.